Hi everyone. I'll bet you thought that example 2 column buckling was finished, didn't you? Well, not so fast. Today I'm going to go ahead and give you a bonus analysis and answer another question about the column in example 2. So the information that we're given is exactly the same as example 2, and even you can use the results of example 2. But now the question is going to be slightly different. The question is, does the column material fail under the compressive stress? Induced by the 10,000 pound load. So what is it exactly that you're being asked to find? Take a moment and write it down if you can. Try to write it down as a mathematical equation or relationship or inequality that must be satisfied. Go ahead and pause if you need to, but I'm going to keep moving forward. So when you're ready to start again, please resume play. I think we're really being asked to check the design, for the stress from the load induced, P, needs to be less than, is it less than, the yield stress. This is what I think we're really being asked. So as we move on, we can start to look at the solution. One of the things we need to look up is the section properties, the geometric properties. For our channel 10 by 15.3, we can look up in the table D4 and find that the cross-sectional area for this section is 4.49 inches squared. We can also know that our mathematical model is something that we've already used in our class many times. It's the definition of stress. I'm going to call this equation 1 because this is the bonus and we're looking at this. So this is the definition of stress, engineering stress. All right. And to be complete, we need to define our terms, where stress is engineering stress in PSI. P is the load, in this case compressive load, and in pounds, force. And A is the cross-sectional area of the member. In square inches. Okay, so we have sigma is less than sigma y. That'll be our equation 2. From equation 1, we can start to plug in and get stress is P over A, which was that 10,000, divided by 4.49 inches squared, getting a value of, I get 2,227 psi. Not very large. And we can check that sigma that we just calculated is in fact less than the yield stress, 36,000 psi. We checks, and we can make the statement that therefore this column does not fail in compression. And with that, I think we're done. I hope you liked the bonus analysis.